Good morning, everybody. Welcome to the stream. Let me quickly go grab my coffee that just finished, and I'll be back in a few seconds. Okay, can't start the stream without my coffee. So I hope everybody's doing okay. Got my coffee with me. And as some of you might have seen on the Discord yesterday, let me pull up the chat. This isn't my Discord. Let me pull up this one. I did a bunch of stuff yesterday. First of all, let me pull up this one. I think this one was funny. So this is basically the parsing code that I wrote yesterday. And then I went back and refactored all of the code, and now it's this. So I took a lot of time, put everything into records, etc. And now at least it reads a bit better. Let me pull up chat on the second window, just in case. Nick.yt. Boom. And let's pull up this one. Okay. Great. Hi Nick. Hi Luke. Luke said hi Nick. Oh no, wait. This is yesterday's stream. Haha, I pulled up the wrong one. My bad. Okay. Amarte says, good morning Nick. How are you today? I'm feeling great. And Sunco Software as well. Nice to have you both here. Welcome. So yeah, I posted this to Reddit yesterday. I thought it was fun. Because if you saw yesterday's stream, like writing this out, it was painful. It looks horrible. I made a small change here to use the new spread stuff for the substring, because it, instead of trim end, I could just strip it off because, well, we know where it is. So that was fun. But I went ahead and refactored a lot of the code from yesterday. Oh, no. And then let me pull up Visual Studio. Let me put up this one here. So before we go into day 20, I just wanted to go over some of the stuff that I made. So some of the things that I did, let's see, I have a part range, I have a workflow, and I have a rule, yes, and a range. So I started parsing out because, let me see where the constructor was. Did I collapse something? Oh yeah, I copied this again to make the screenshot, so let me just remove this. Like this. So we had the workflows and the parts. So I made a record for the workflow, started using records, and it's just a simple splitter, and it also uses the rule that I made here, which was this one. So now it has all the properties on the same level. It's instead of another extra level deep. So I like that one. This way I could also make the parsing less awkward, because as you saw from this one, I had like first I had to split on, let me see, I had to split on this one and then record if the value had this one, and then do another sub-select and then have a nested level here. So yeah, this is a lot cleaner at least. So I had the rule, had the parsing here, which is a lot less complicated. And I had some stuff that you can pass in. So like is match for part and a part range, and is a partial match. These are for part ranges. I'll get to that in a bit. I have the part here, which basically has the 4 properties. It has a sum property to just, we have it all locally, why not? This one is needed when you set properties to init, because you can declare a part like this, a string name, right? But you can also write it more in the traditional way with properties. And having an init means this will be read-only and only be set at initialized state. And if you want to make sure that you have a constructor that takes care of that, you need to have this attribute or the compiler will complain. Good coffee. Well, cappuccino, but it's my coffee. I used a destructor here, and for C#, sadly that only works for value tuples, so I wrote some extra extensions. So I did the split on the comma, and the raw just thinks that it will take out the edges right here, because as you know, the part is accolades followed by 4 pairs of data. And I checked the input, it's always in the same order, always the XMAS for Xmas. And I saw a meme on Reddit about somebody figuring out that it spelled Xmas very late, just like me, so I had an aha moment there. So I stripped off the outer characters, the accolades, then I split it by comma, and then I did a short parse, skipping the first 2 characters. And I can do that because it's always in the same order. So you have the X, then the M, the A, then the S. So we skip off the letter with the equal sign and we parse that as a short. Values never go above 4000, so I used a smaller data type here. And I made this as value tuple 4 just so that I can do this deconstructor. So what that thing does is very simple. It just calls a .as, and then it expects 4 things here. And this one takes us the input, and basically what this one does is it will do a to array to pull in all the values and have support for the when they don't exist. So it goes again here. So I always have, like, if the length of the array is not long enough to fill it, it will pass a default. So you can always work out, if you say you want this input of this INumeral range as a value tuple of 4, it will just create that. And this is just all plumbing to make sure that you can do this. So you can have 4 values and you can assign them to these 4 properties like this. So it's not the best. I still think that it would be nice if they have a deconstructor for array types as well. But this is the closest that I could build to make it like that. Then I have based on the char, and I wanted to use it like this, name of and then pass off the element, because I think that just reads nicely. But you can't use name of and take the first character, because this no longer is considered a constant, and so you can't use this construction. So I made the concession to have the primary function work off of a string, and then have a char overload so that you can have the char data type and make it work, and then cast that to string to call that overload there. So this is a small concession just to make sure that I can not have to declare 4 more magic characters, because they are already inherently defined here. isMatch just calls rule with isMatch with himself, so I have the properties both on the rule and the part, and I just have the logic defined in one place. And then I have a process logic, which basically lets you feed all the applicable workflows, the workflow that it needs to start in. So this means that you could use it for recursive logic and start at a deeper point. And the valid states where you want it to end. So it will keep going until it arrives in an end state. And I didn't add the sanity checks here because it was already pre-tested that this would never fail like this. So that is my part logic. The workflow and rule, I think we had that already. Then there is a part range, which makes use of a range. And I defined the range using the iNumber interface. I saw that a few days ago on Captain Coder's stream, somebody used that and we all just were like, oh, that is cool. And what this lets you do, if you write it in the correct way, this lets you have the strong type for byte, short, int, long, ulong, whatever. Anything that identifies as a number and implements this interface, it will work. So that is something that I thought was really cool. So now you can have a reusable code whenever you want to define just a numeric range. I have a small sanity check for the constructor that the min has to at least be, can't be larger than the max, so they can be equal, but otherwise it has to be smaller. And I have a function called split. So this one lets you take the range and divide it into two. And I don't have a sanity check here for if the value is within the range. I should probably do that. And what this one does is it lets you specify a number and whether to include that in the lower or in the upper part of the new range. So this one will take, like if you say I have 100 to 500 and I want to split at 200, you can say I want 1 to 200 or 1 to 99 and then 200 to 500, etc. So this one lets you do that. And since you don't know the type of number, you need to have like a +1 and a -1. And the cool thing is, if it's an I number, it will have properties for 0 and 1. So you could just do the value you want to split at minus the type definition .1, and this one will make it work. So this is really, really cool in my opinion. So you can do some basic math. So for here, like these types, implement this operator, so this is fine. But if you want to put in a const value or a hard number in here, that won't work. So what you can do is you have this, the 1 and the 0, etc. So you can check for value 0 in the type that you supplied, as well as having the type definition for values of 1, etc. So I think this is a really cool way to do this. So this will work for any number type that's below it. So then we come to the part range, which is really similar to the part. And it also, I have an implicit operator here that you can cast the range, so this value itself, just into a number of the type of range. And this one just means that you can convert this to the length of the range by implicitly, right? So it takes the max minus min plus 1. So no 50 char long tuples anymore? Well, this took a hell of a lot of time to write out. And I did a lot more, I will show you in a bit. So I'm not sure. I might still do my tuples because that's just my comfort zone still. But yeah, this is also pretty nice if you look at how it's done. But this feels very enterprisey way to solve a coding puzzle, right? So we have the part range here. Seriously, nice job. Thanks. Yeah, I was proud of myself after doing it. And I made a grid, a grid system as well in a similar way that I think is even cooler. So now the part range just takes for ranges with the same values. The sum logic has this implicit conversion for each. So this one spits out the length of that range and they multiply together like this. So that was, I think, was pretty cool. The initializer, it has a shortfall that it will only create one of the same size for every range. If you need to have this differently, you could add a new constructor that lets you specify multiple overloads. Then I have a property that lets you the same as the old one, but it retrieves a range instead of a single value. And you see here I cast range, I use it as range of short, since that is the type length that we want. But you can reuse this for range of int, etc, etc. This is the same, pretty much the same as the normal range code. Then I have the needs split. And basically this checks if it has a partial match. And let me just go to that logic right here. I have for range, I have is match and is partial match. So is match tests for the worst case that the entire range falls within the needed boundary, so that the full range adheres to the rule. And is partial match guarantees that at least some of the rule fits it, right? So if you want to take it smaller that, you make sure that the biggest value that is in the range falls below the threshold, and same for the other logic. If you want to make sure that it's larger, you make sure that the smallest value falls in that threshold. To do the partial, you test against the opposite properties. So if smaller, then you make sure that the smallest value is at least smaller than the threshold, but you don't guarantee here that your largest value is larger than that threshold. So combining these two lets you get all the information that you want about how something is overlapping or not, or exact matches, etc. Let me see. So I had the part range here. So that is basically what this needs split does. It says, okay, I need to have at least a partial match, but not a full match, and that means that I need to split this data based on this rule. So then you have the split. It actually splits out the range into two parts based on the rule that you give it. It does a validation, like if this is a clean forward without any constraints, it will show an exception. And then it will do this basically the same match. So I could just do here needs split actually. So we should probably do needs split rule, right? Basically this is the logic that validates, and otherwise like this. And then I just call split on the rule, which is where the logic takes place. And here you see this is the value that we want to split on, and depending on if it's the smaller or larger case, we want to have it included in the lower bound or not. So you take the inverse of in smaller to know where the actual value that you're splitting on needs to go in the upper or the lower range here. Then I had to do this, which was a bit to figure out, but I think it's nice. And basically you create a clone of the current part range, and then you change the immutable data with the width, and you can only do that in this constructor. So you create a copy of the current range, but you change the thing that we're changing on. And since this is a char, I explicitly wrote them down here. I should probably have done this dot to string and then do name of X, right? I think this is probably the cleaner way to do it. So let me just do that now, right? And now we have no magic characters anymore, and we can't mistype because we have them here. This could be even cooler with a predicate, so that you specify a pointer to this once and then use that twice, but it's fine, it's fine. So yeah, I like this right. But there we have a invalid rule dot, let's do it properly, name of rule dot, no, we want the uppercase for the type, rule dot, and then we have name of rule dot attribute to test, and this rule dot attribute to test, like this. So now we have the exception written out correctly as well, and otherwise we have the validation there. And this is the basically the part 2 logic, which basically says, and I've done this in a static because I was trying to figure out how to make the recursion work with the IEnumeral, etc. I could just make this one non-static, but it's fine. This takes in a range, which should probably just be itself, all the workflows, where to start and what the end states are, similar to the other validation. And this one will keep going until we are not in an end state, or we haven't have split up yet. So if we do a split, it will stop processing, and it will only return once we are in an end state. So if we end up here, we're not in an end state, we won't return the value. Instead, we have this split up version here, because this basically means that we've split up and we can't take the current one further. So this makes the current state die and process the children instead. So this one will recurse and do that. So this one takes a split and uses the lower and upper, and I requeue them in the current workflow. I could, based on if the rule was the lower or upper, decide which one of these could go to the next workflow. But I just thought that this makes it so much easier to understand and clean that having a one-on-one match where it just does one extra loop doesn't matter here, and I prefer the clarity of the code rather than complicating this further with ternaries, etc. So I take a suboptimal approach here that I say, okay, we will just enter the same level again. Basically we did the logic, but since we need to split, we will just do it again, and now with one that will fit exactly and one that won't fit at all. So, and that means that one workflow will go through this and hit another rule in the workflow, and the other one will hit the same rule in this workflow. So yeah, this is fine. At least I think it's fine. That's the workflow, these are the rules, and I think we've covered everything that I've done so far here. So yeah, that's basically day 19 redone, and now the part 1. This one doesn't need to be done. So this is part 1 and this is part 2 now. So I have the parsing code is 2 lines. The basic getting the answers is 2 lines, and that's it. Oh yeah, I had something else that I made that I thought was cool, and it was a grid and a grid location and a direction. So let's start with the direction. Basically there are 4 basic directions. You can set no direction, and then there are 4 directions and you can combine them. For doing some magic later on with rotation, I record the first and the last bit that can be set for any direction. And we'll see about that why. So the first bit is just a 1, and this one, since it's a flag of 4, we'll need 4 bits to denote each value. So the last bit will be the 4th bit. Even though we use a byte, only half the data gets used. So you could basically pack 2 directions into one. And I have some properties here. So I have the value that holds the actual value for the direction. I have a property to check is none, so just that you can move on. I have a has for each direction because you can combine things. I have a pop count, or how many bits are set in this value. I have a name, which right now only masks to the 2 directions. I still need to do the combinations here. I didn't have time for that yet. I have something that converts a direction into a row and column offset. So I will show that's basically here. So I have a grid location, which is basically a row and a column with all sorts of extra stuff. And basically this builds up the grid location as or the direction as an offset. Note that if you have left and right set here, this one will cancel out to 0, so that is fine. Then we have the rotation logic. It checks if there is at least something set, because if no direction is set, there is nothing to rotate, so that's an edge case. And here I test if the last bit is set. I first have to remove that last bit, shift everything to the left, and then add the last bit, the first bit. And the same for the rotate left. If the first bit is set and we shift it off, we want to make it appear at the last index again. So then we remove the first bit from the value, and we don't actually need to do that. So you could just take this part away because you shift to the right, so it falls off anyway. But I think this was nice and clear to show the intention of what you do. And then you add the last bit back in. So this is like a wraparound for bit shifting. And if it's not, we can just bit shift easily without an issue. And then I wrote some tests just to make sure that everything works. So I start with value up, and then I test, and I do 4 rotations, and then do step rotations, and make sure that everything works. So just because like making a small mistake here is easy to do, so I just wrote a small small set of tests. So then we have the grid location, which is basically a row and a column. I have a check inbound where you can pass a row and call dimension of your grid. So it's a simple check. You can also pass in a grid object that I've created above that I will show, and it will just pass those dimensions in there. And the Martin says, I can clearly see you had enough with directions and especially rotations. Yeah, yes. So this is just the initializer. So then I have functions to move. So I have one up, right, down and left. And this one takes a direction which has an implicit conversion, as I said, to you can go from the current value to the direction, and you can go from a direction to a grid location. So when you do different up, this is actually a byte, but the byte converts to a direction, and then this one converts to a grid location. So then you do it like this. So yeah, I thought that was pretty cool. I have the operators here, so you can turn a value negative by just putting a min in front of it. A plus does nothing. You can combine them, it will add the values, subtract them, multiply them, divide them, and then also just combine and subtract a direction. So this is just all basically how you can move about in a grid. And you can do it directly by combining stuff. And then I have the grid itself, which is basically just rows and columns. And I have 4 functions here that just lets you move based on the current position. And I added support for wraparound. And if you don't want wraparound, it will throw an error. Or if you don't want that behavior, it will just return the same value again. So I thought like this will probably come in handy for a lot of the stuff that we will need to do. So I haven't rewritten anything yet to use it, but yeah, I figured I needed to take some time with records and all of the new stuff. Well, records isn't new stuff, it's stuff from before, but yeah, I had some fun with it. Question, why records for direction and location instead of structs? Basically because they are immutable normally, and I just wanted to use the new system. So I intend to not modify them, but instead just change them. So yeah, it could be for location. You could do, you could make a struct and have the value actually change. But this one is set up to just create new values, and that's because with all the walking, you constantly want to add new ones anyways. It could be a struct just fine as well. I may be doing too much with record, but yeah. There is no clear reason why I chose for record over struct. Mostly just to get the hang of all the stuff that comes with it, and having like the way the constructor works, the way you have to satisfy things, and then these become immutable properties. Like for grid location, if you see this as a location, this means it never changes, and any other location would be its own thing. But I can also see where you would be like, okay, I'll make a location be more like a pointer to a location inside of a grid, and that can change. So just basically how you look at it. And Mate says, okay, I'm asking because records are managed types, landing on heap, but good otherwise, and it's true, they are immutable by default. Yes. So yeah, I think we've caught up and are ready to do day 20. Was it a hard one today? I'm just wondering. Let me start reading day 20. Pulse propagation. With your help, the elves managed to find the right parts and fix all of the machines. Now they just need to send the command to boot up the machines and get the sand flowing again. The machines are far apart and wired together with long cables. The cables don't connect to the machines directly, but rather to communicate modules attached to the machines. that perform various initialization tasks and also act as communication relays. Modules communicate using pulses. Each pulse is either a high pulse or a low pulse, and when a module sends a pulse, it sends that type of pulse to each module in the list of destination modules. Okay, so is it like Morse code? There are several different types of modules. Flip-flop modules prefixed by percentage are either on or off. They are initially off. If a flip-flop module receives a high pulse, it is ignored and nothing happens. However, if a flip-flop module receives a low pulse, it flips between on and off. If it was off, it turns on and sends a high pulse. If it was on, it turns off and sends a low pulse. Oh, wait, what? Okay, so that one sends a pulse as well. Okay. Okay. Let's see. Don't know. I've done part 1 only, got in late and wrote a lot of code for that one. Okay. So I'm guessing I'll stop watching before you do part 2 and come back to watch the rest after you give it a go. Sounds fine by me. So basically, if this thing receives a pulse, it will send off another pulse if it's low. And then the value of that will be based on its current state. Okay. Conjunction modules prefix ampersand remember the type of the most recent pulse received from each of their connected input modules. Okay, they initially default to remembering a low pulse for each input. When a pulse is received, the conjunction module first updates its memory for that pulse, and then, if it remembers high pulse for all inputs, it sends a low pulse. Otherwise, it sends a high pulse. Okay? Fine. There is a single broadcast module named Broadcaster. When it receives a pulse, it sends the same pulse to all of its destination modules. Okay. Here at Desert Machine Headquarters, there is a module with a single button on it called aptly the button module. When you push the button, a single low pulse is sent directly to the broadcaster module. After pushing the button, you must wait until all pulses have been delivered and fully handled before pushing it again. Never push the button if modules are still processing pulses. Pulses are always processed in the order they are sent. So if a pulse is sent to modules A, B and C, then module A processes its pulse and sends more pulses. The pulses sent to modules B and C would have to be handled first. Okay. Okay. So it's a queue. First in, first out. You broadcast, you send it, you handle it, and then you put more stuff on the... Okay. I can see that. The module configuration, your puzzle input list. Each module, the name of the module is preceded by a symbol identifying its type, if any. The name is then followed by an arrow and a list of its destination modules, for example, broadcaster ABC, and then we have those, the ABC and the inverted one. The inverted one, okay. In this model configuration, the broadcaster has 3 destination modules named A, B and C. Each of these modules is a flip-flop module as indicated by the percent prefix. A outputs to B, which outputs to C, which outputs to another module named inv. Inv is a conjunction module as indicated by the ampersand prefix, which, because it has only one input, acts like an inverter. It sends the opposite signal of the pulse type it receives. It outputs to A. By pushing the button once, the following pulses are sent. Button. Low to broadcaster, low to ABC, A sends high to B, high to C, high to inverse, inverse sends low to A sends low to B, low to C, low to inverse, okay? After this sequence, the flip-flop module all end up off, so pushing the button again repeats the same sequence. Here is a more interesting example. The module configuration includes the broadcaster, 2 flip-flops named A and B, a single input-output conjunction module, a multi-input conjunction module, and untyped module named output for testing purpose. Okay. The The multi-input conjunction module con watches two flip-flop modules, and if they're both on, sends a low pulse to the output module. Yeah, this is what happens once. Now both flip-flops are on. Con remembers a high pulse from each of its two inputs, pushing the button the second time does something different. Okay, the flip-flops are off. Now con remembers a low pulse, sends only a high pulse to the output, push the button the third time, turns on. Okay. However, before B can turn off, the pulse sent to con is handled first. Oh. Sorry, I need a sneeze button. It came on so quickly that I couldn't go into OBS, find the mute, etc. Sorry. Finally, with A on and B off, push the button fourth time, completes the cycle. A turns off, causing con to remember low pulses and resorting all modules to their original states. Let's see. Thank you. Thank you. To get the cables warmed up, the elves have pushed the button 1,000 times. How many pulses get sent as a result, including the pulses sent by the button itself? Okay. The first example, the same things happen every time the button is pushed. 8 low pulses, 4 high pulses are sent. So after pushing the button 1,000 times, 8,000 low pulses and 4,000 are sent. Multiplying these together gives... Okay. Nice. Time to pull out the big numbers. In the second example, after pushing the button 1,000 times, this many low, this many high, multiplying these together gives that. Consult your module configuration, determine the number of low and high pulses that will be sent after pushing the button 1,000 times, waiting for all pulses to be fully handled after each push of the button. What do you get if you multiply the total number of pulses sent by the total number of high pulses sent? Okay. I think this will be a tricky one. So many stuff to do wrong. But let's get started anyways. And I wonder if I'll finish in time, because it's a short day today and we have lots of stuff to do and the kids have stuff to do, and so I basically have a hard out in about 2 hours. So I wonder if that will be enough time. So I might have to do a part 2 of this. 20, okay, so input becomes this. And now there are so many rules that I need to make sure. Flip-flop, conjunction, broadcast. Okay, these are the rules. Come on, I just want this. So we have record module. Let's do this. So we have flip flop conjunction and broadcast. Okay. Boom, 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 boom. Those were the 3 types, right? Oh yeah, the button. Const, graag, flip, flop, marker is this. Flip flop is percentage. Conjunction marker is ampersand. let's see, this one will have a public bool. I just think this needs to change constantly, so why not? Public bool, so this one becomes signal. So this one either be low or high. Default will struct field with field dimension. Oh, sure, okay. Right, in a constructor for a struct feels wrong. Either on or off. If a flap mobility is a high pulse, it's ignored. I wonder if I should implement these all and just have a general interface for them. Because basically you need to have a module connected to one or more others. State, tracked state for others. Let me just do it differently. Let me do a class broadcaster. Maybe I'll do interfaces later, but for now, I don't care. So this will be a dictionary of string, comma, bool. This needs to remember, where was that part of the code? Broadcast here, after pushing the button with the pulse out, pulse in order, the model configuration, blah blah blah. Or was that the conjunction one that remembers all of them? Okay, initially default to remembering a low pulse. Okay. Okay, fine. Let's see. Okay, so that was the conjunction module that I was thinking of. This would just be a hash set of string targets. Broadcaster has targets. Either on or off, so initially off. Ignore it, nothing happens. Center loop pulse. So the percentage sign, can it be connected to more? I think so, right? Yes, it can be connected to more than one. So you have a broadcaster, and basically a flip-flop is a conditional broadcaster. Let me think. We will have I think we need to have a global registry of all the modules. So we'll have a dictionary, string, and then modules, new like this. So let me see if I can design one that is general enough for all of them. Because basically we have, let me just make a class. This. This one has targets. Get target set. In this case, we will also have a dictionary of string bool remembered inputs like this. I will just keep track of it for everybody as a general case, and I will just then I think I will make one guard object to do all of the logic and then have a switch to determine how it should proceed. Let me think. So we have it's if it's on. Let's see, either on or off. Initially off. Bool. Okay, let me just keep going here. On or off. We have a public void receive pulse bool high. Okay. Let's see. If high. Now we have our logic. Let's see. If a flip-flop receives a high pulse, it is ignored and nothing happens. Do it. Nothing. Okay. Else. Boom. However, if a flip-flop module receives a low pulse, it flips between on and off. Okay. This one means on is not on. If it was on, it turns off and sends a low pulse. So this one would actually be an I enumerable of bool. No, it will be a string target bool value like this. And this one, would it do it multiple times? No. So this can yield new pulses. So this one will be back. My provider decided it's a good time to perform some sort of action that causes a total failure. No internet for me today. I'm on the phone now. Oh, well, thank you for coming back to me. It's appreciated. Basically, if you missed it, what I've decided on is I will just make one class right now that can handle everything, and then I'll see how I divide it up, just to make it somewhat easier. And then we do if on for each target and targets yield return target comma, and this one will send off a false. Okay. I miss all of your coding dropped when you were reading about 1000 steps. Okay. I haven't done much. I was trying to figure out some of the stuff. So I've declared some markers here, and then I was just contemplating how I was going to do this, because I was have like a general module and then specific modules. For now, I think I'll just work in one class. I make one super class that handles all the logic. I will just write it all out, see what everything is that I need to track, and then I see how I will switch that on and off. So for now, I will just put all the logic here, and then I'll go from there, because trying to engineer it at once now will be counterproductive for me. So this is basically the flip-flop. Then we have the conjunction. Alright, thanks. Okay, no problem. Remembers the type of the most recent input received from each of their connected inputs. So this will be string from because we need to know where we came from. And this one will do if not remembered inputs, try get value from out var current. Current is actually current defaults to high, and now we do let's see, convention. They initially default to remembering a low pulse for each input. Okay, false, my bad. When a pulse is received, the conjunction module first updates its memory for that input. Okay, so then we do, why does it even matter? Does this mean that we have to figure out everything that at one point will connect to this and then initialize that state? So you have to do first a warm-up to false or something? To do might have to work out everything that could connect and pre-initialize their values false. Okay. So this is it might be an issue if it doesn't work. So basically this makes no sense because we were setting it here as well. So then I can do that add, and it will be high actually. So it doesn't really matter. And else we do remembered inputs from is high. And then we need to make sure that they're all high. I think when the pulse is received, conjunction first updated memory for that input. Then if it remembers high pulses for all inputs, it sends a low pulse, otherwise it sends a high pulse. Yes. If not, remembered impulses that any sure, and then we broadcast. Let's see, then we set a high pulse. Okay, so we broadcast true. Okay, so this makes me think that I need to construct like a reverse for something that at one point points to one of these. So I might have to build that just to make sure that I can set up the initial state correctly. Is there an example here where they do that, by the way? No, but because they only did A points to inf and never another one. So I don't think they have an example like that. Okay, maybe it just won't be an issue. So that is the conjunction. There's a single broadcast module. Okay, so this is easy. So broadcast basically just does this. And what does it do? It sends the same pulse to all of them. Okay. Okay. So these are the three states, the three things that we have. So this is pretty easy. So what I could just do is have a public type module type get set. Module type. And then we have a hash set of string with targets. So we do type is type, targets is targets. And this one makes it set up. And basically I can just do switch type. Come on, break it up. We don't support type. And this will be type of string. And I need to have the button there as well, by the way. Broadcast, flip-flop. And this one is the conjunction one. And let's keep this to do here. Bum, 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 bum. Like this. Bum, 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 bum. Let's see. A button will just go to broadcast always, right? There's no input called button here. Nope. Okay. So we have our own mapping for button. Case. Yes. So this one will yield return module type dot button, comma, and this one will be high. This should always be a low one, but it's fine because that one will start. So basically I can create a button and send it a pulse, then it will be fine. The one with the output will actually be an issue. Let's write the parser here. Okay. So we do raw.split by like this. And I saw spaces between here, and I don't think that I've seen those in the input actually. No, they were. Okay, it's always spaced. Okay, so the format is consistent, that is fine. So we do var parts is this. These are two parts. So I can do. Can I do name string name targets? Name targets is this. Okay. Module type is name um, 0 actually. Switch. This one will be flip-flop marker. Module type dot flip-flop. Then we will have the conjunction marker. Module type dot conjunction. No, module type conjunction. This. Now we can do name switch. I should probably call them like this. So we have the explicitly named ones and the ones that we named ourselves, like this, and then we do name module type dot broadcaster. Module type dot broadcaster. Then we have name of module. Come on, module type dot button. New application. No, argument exception. Like this. Name of raw. Enable to parse as a module type. Boom. And this one will be, let's see, name. Right. So in here we have, we first try to base it off of the first character, which will work for those two types. Otherwise, we will base it off of the full name, and if that doesn't work, we have something that we don't account for. And we also need to have a name here, so we have a, come on, oh wait, public name, I already had that. Oh, okay, it added that. Okay. Okay, it can read minds. And now I wish I could do more work here. So now if I had a traditional switch case, I could also do the name based off of this. So what I could do now is maybe not so nice, is name dot trim start, and we do marker, flip-flop marker and conjunction marker. So it will take those off and be the literal like that. So this is the downside to using this statement. If I would use a real switch statement, I could actually do two pieces of work there. But it needs to return this, so it's fine. So we have the name parsed, now we have the targets, and we do targets is new this, and this becomes targets.split by, like this. Okay, so this one will trim off the white space after the comma as well, fills an IO numeral, puts it in like this, and now it's initialized. So this is fine. The only thing that worries me is this conjunction type, where I have to do the inverse and see where the, how do you call it? That I have to map everything that maps to it, just so I can set up initial state. And I kind of want to do that. Anyways, let's not worry about it for now and see if the input fails. Let me see. We have the test input here. So in the first example we have this, yes. So you have, okay, const int button presses p1 is 1000. And we have the expected values. I have those in constants here. Let me put this here as well. Boom. P1 test means this one. Okay. So now let's do the parsing. So let's do modules is input 2 lines. Select your module X. This is the raw one. Boom. No, not 2 lines, 2 lines. This, and then 2 dictionary. I can just do it like this because it will take the object. You only need to specify the key. The rest is implicit. So these are the modules, and I need to modules.add. This one will be button. Actually, I can do it like this. Name of module type button. This will be name of module type broadcaster, like this. And I should probably have this one as a separator defined, just to make it nice. So const string module and target separator equals this. We reference it a few times in code, so let's just map it. And a few times is 2, the minimum amount of time needed. So let's also do it like this. And this one is new module like this. So now we have our button in there as well. And the name would be button. Okay, let's just do it like this. Var button is this. Button.name button. Okay. We should declare this globally because this will be the one that we press. Like this. So now we do for int I is 0, I smaller than p1, button presses p1 plus I, and now we do press button. No, let's do emit signal button. Actually, for each var signal in button dot receive pulse. Null, comma, false. So this one will start of the chain. We will press the button and then it will give us things to do. So let's do queue and this one will be a list of string target bool value. So string target bool value pulse q is new. And then we do int low count is 0, high count is 0. And let's make this a long, whatever. UL. Sunco Suffer says, it got to go, we'll watch the recording later this evening, have a good one. Okay, thank you for stopping by, it was nice to have you as always, and I hope that I bring you some enjoyment with my coding. And I see that I have the scroll size of the code a bit small, so let's pump that up so that it's better readable. If somebody has comments on anything, please feel free to drop it in chat. I don't mind any feedback or suggestions. It's always nice to see people in chat, so thanks. Okay. Don't forget, hit that like button. Yes, very good. Let me do that right now. Click, boom. Let's see. So we receive a signal, and this one is basically the thing that we need to we should like pulse q.enq signal, and then we do while pulse q.count larger than 0. Var pulse is pulse q.deq, and then we do modules.try get value. Try get value. Pulse dot target out var out var module dot receive pulse value like this. No, receive pulse like this. Oh yeah, sure. We do for each. We need to actually have a list here. List string target bool value new pulses is new. Let me think. Because basically this one will return a set of pulses that need to be handled, but they all need to be handled before the result of those are handled. So let me think before I mess this up. Actually, I think I need to do var signals is this dot to array, and then I need to do for each var signal in signals. Let me think, because you need to. It sends out, and it needs to send all of them out, and then the responses. Yeah, I think if I queue them in order, that should be fine. Yes. I think this is fine. So for each parse signal in this, and then I can do just q pulse q dot q. I think this is fine. Let's see. There's no current. Yeah, this will be. I need to cue where it's from. String from, like this. This will be okay. Button name. Actually, it will be null. And I need to enqueue. Let's just make it in this case string from. Let's just let it emit its own name, which is fine. So we do name like this. And this makes the whole thing easier. Right. Okay. What's the issue here? Okay, something got lost there, that is fine. Receive pulse. This will be pulse.from, pulse.value, like this. Good. Because this one will do them in order that they're added, which is fine. So every level will be queued one at a time. I think this is fine. This one will be if pulse dot high dot value high count else low count, like this. Yes. And I wonder if the first signal needs to be added there as well. I think so, right? This is low, 1, 2, 3, 4, 4 low, 2 high. Is that correct? 8 low, 4 high. Wait, what? Let me see the original one, sorry. 1, 2, 3, 4, 5, 6, 7, 8. Yes, so this includes the button 1. So let me see. And I think I have that here as well, because I just enqueue this signal. This is just the button press to get it started, and here we dequeue, so this should be fine. Console, the right line. First wave sent low and high pulses. Cool. Low count, high count. If I is 0, like this. Okay. And now we do P1 is low count times high count. I think, right? Times. That's fine. Oh, but this answer is already a long, so I really shouldn't have to convert it into a U long, so I can just do a long. since I count up, it always makes sense to make them unsigned, but yeah, let's not mix it too much. I think I can actually run this now. Program, let's run day 20 and see where it breaks. But I think this should be able to be fine. Let's do console, outline, part 1, P1. Okay, let's see what this does. It's a lot of code written. Okay, so how high are our counts? They're very high. Okay, and this is wrong. Okay. Why from button? Ah, okay. What is the iteration count? 0. Wait, what? This is weird. Okay, let's see. Oh yeah, from button, and the module is the broadcaster, right? Nope. Boom, boom, boom. Ah, the target is button here as well. That's wrong. Did I do this wrong? No. Let's see, button. Targets. Broadcaster. Okay. Okay, let's see. Set next statement. Let's see. So we're the button. Like this. Okay, that makes sense. Button sends to all, including button. No. Broadcaster sends back to button. No. I had the name here wrong. The button just triggers the broadcaster, and the broadcaster has its defined type. I just had a name off there. Boom. Object reference not set to an instance of an object. Nice. Remembered input is not initialized. That is fine. Where is my constructor? Dun, 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 dun. I can basically remove this constructor because it's not used. Let's do this is new. Not num. New. Remembered inputs is initialized here, so that is fine. Boom, 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 boom. And P1 is set to 0. Okay, this is interesting. Let's take it from the top. So now the pulse queue has a value. The pulse queue sends a false to broadcaster. That is nice. If it's value, we increment low count. So I don't know how it could ever be 0 there. This code doesn't need to be here. Boom. So now the module is the broadcaster, and this one will receive a pulse. So the broadcaster, for each target, it will return those. So that is fine. It will enqueue the signal, which will go from broadcaster to A. Value will be false, etc. Okay. So this seems fine. Pulse queue now has 3 items, which is fine. And this is also the order in which it needs to. I wonder how this could have been 0, because okay. Oh, the high count is 0. It's never a high count. Ha, that's why it's 0. Okay. So we have the low count, 6,125, which is wrong because it can't be. So it would be 8 low and 4 high. That's interesting. Let's debug the code and make sure that we are doing the right thing. So let's see. me run this and take the example flow here. Because basically this is the state that we need to do. This is what we expect. Expected for test. Boom. So let's just do console.writeLine. This one would mean button. Come on, button dot name. And this one would be just low. Aim of signal.name, target, right? Actually, I can just do signal dot value high low, and I can reuse this to build up the other ones. What's the issue here with signal.target? Let me just stop running for now. Target is not null here. What? Oh, my bad. So I can do signal.from, and let's do this if I equals 0, so that we print out the first flow here. We do the same here. Let's see, if we run this, let's see what it spits out compared to what we expect. Button low to broadcast, so broadcast low to ABC, A does low to B. Okay, so these are wrong. And then inf does nothing because it's not set. Okay. Okay. Basically, what were those ABCs? A is a percent sign, and a percent sign means the flip-flop. So the logic for the flip-flop is wrong. Flip-flop, that's conjunction. Flip-flop are either on or off. They are initially off. Yes, I also need to make sure that flip-flop on doesn't really matter here, but if type equals flip-flop, on is false. Right? Okay. Initially off. If a flip-flop receives a high pulse, it is ignored. So flip-flop, if high, do nothing. And I think the broadcaster sends a high, right? When it sends the same pulse to all the destination modules. Okay, let me see the button. So maybe the button doesn't send a low. Well, D sends a low. The broadcaster says low to A, and this one then sends high to B. So how does that work? Let me check. If it receives a high pulse, it is ignored nothing. If a flip-flop receives a low, it flips between on and off. When if it was off, yeah, okay. If it was off, it does a high pulse. Otherwise, it turns off and sends a low pulse. Okay, that was my error there. basically if it's now on, it needs to send a high pulse. Basically, it needs to do this. Let me check. Low, 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 high, high, high. Then inf sends high. No, inf should send a low, or should get a low, and then the A should be high. So let me check the inverter again. It sends high to inverter, then the inverter sends low to A. Okay. Let me see. Sends, okay, then if it remembers a high pulse for all inputs, it sends a low pulse, otherwise it sends a high pulse. Okay, so I send a high because for everyone that we know, but what is all inputs? Is that every, let me see. Let me see. Because it only has one input, it acts like an inverter. It sends the opposite of the pulse type it receives. It outputs an A. Okay, wait. Let me read the conjunction again. They initially default to remember low. When a pulse is received, the conjunction first updates the memory for that input. Then, if it remembers a high for all, it sends a low, otherwise it sends high. Okay. Let me see my logic. The flip-flop, no, the conjunction here. Okay. If there's not a low, it sends. There is all high, it sends low. Else it sends high. Okay. So it sends the opposite of this one actually. Oh, okay. Let me see. Bool. Not all high is this. I should do it actually all high like this. All value is true. And we send the inverse of not all high. I think this is better. Let me run this again. Oh, so now it completes part 1, so it's correct. Okay. Check, check, double check. A, low, 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 high, 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 low, 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 high. Okay, boom. 8 low, 8 high, that's the value, okay. Okay. Progress has been made. Test, and I made a mess of my code. Where's the test switch here? Is false. Boom. And now P1 is this big number. Ooh, my answer is too high. I should have tested the other ones first. Let's see. Okay, let me see. So let's take the more complicated example and do that. And we should run it 4 times, I think, right? Oh, the second example. Wait, let's get the second example. A more interesting example. Okay, sure. Boom. Input. Let's do it like this. Okay. Let's also update the expected answer here. Huh. Okay, so let's see. Ooh, that's a long. Jesus. Ah, I didn't turn test off here. Okay. Let's put this at the top so just that it's easy to toggle. Let's run this. Okay, it's still not correct, so that is good because we can find our bug now. Broadcaster low, low, high, high, low, and here it says high. And then high, low. Okay, so this con, what's the con? Okay, let me see. This module configuration includes the broadcast to flip-flopped, single input inverter, and the multiple input conjunction module con. Multi-input conjunction con. Why? Because it's only A that moves to con. Let me see. Just because it says con, inf is a single input and con is a multi-input. Oh yeah, because both B and A, so this is exactly what I said. So I need to do the reverse and catch the initial states for the con. Okay, so that's a pain, but let's do that anyway. So let's do that. So here we do this. So var let's do modules where x dot the value dot type equals conjunction. Let's select x name key actually, and then we need to have var find inverse of this. And this is basically a new hash set, actually, new hash set string. So now we do modules where x dot targets value dot targets intersects finders of dot any key. No, actually I need to do it the other way around. I need to do for each string name in this one. I can just do it like this. I need to do this. Modules where targets dot contains name. So we can do for each bar inverse in this, and then we do we precede, we do modules name dot no. Remembered inputs.add, and this will be inverse.name, false. Right, let me just go to definition. This one starts as low, yes. This should never happen actually. Throw new argument exception. Our inverse finder should have caught this case. Let's just take all of that away. And let's do a public void add register input string name, and we just do remembered inputs that add false. So this would be the clean way to do it, I think. So we just do add name comma false. This is the default state. Const bool default state for remember inputs is false. Let's make it nice and do it like this. So now in our code to do this, we can do a register input like this, and this should take care of the second example not being correct. Boom, and it passes the test now, so that is fine. So let's switch back to the real input. So this was exactly why I wrote that to do at the start, just to make sure that I would account for this if I have to. So if there was a bug, this would be the first thing that I would just check. Woohoo! Part 1 done! Yeah! Fairly smooth, not too many obstacles. Let's see. The final machine response for moving the sand down to island has a module attached named Rx. The machine turns on when a single low pulse is sent to Rx. We set all modules to their default states, waiting for all pulses to be fully handled after each button press. What is the fewest number of button presses required to deliver a single low pulse to the module named Rx? Okay, I will have to check that. Amate says nice, congrats, thank you, it's appreciated. My hands are getting cold, I didn't turn up the heat hard enough, I think. Amate says, okay, I'm off now, we'll watch later. Yes, don't want to get spoiled. Thanks for keeping me company, and I'll see you in the Discord probably. Let's see. Single module name Rx. A machine turns on when a single low pulse is sent to Rx. So I don't understand this yet. I linked the code in Discord in case you want to have a look, but it's just part 1 pro. Yeah, no worries. We set all modules to their default states, waiting for all pulses to be fully handled after each button press. What is the fewest number of button presses required to deliver a single low pulse to the module Rx? Okay. So is this one in here? It is. Okay. So now you probably need to construct a reverse state machine to figure this out. So yeah, basically you now have to build the machine in reverse, right? So you have to go from Rx to MF and then boom. And I wonder if you could use memorization for parts of this, but I'm not so sure. Because basically this becomes like a register. Like each of these values. Basically, you have to be able to see how many loops it takes for something to happen. This will be a pain. Do I even have the... Okay, let me see what happens when I do this a few times. Let's see if we can spot a bit of a pattern here. So 9 low, 33 high, 29 low, 84 high, 38 low, 114 high. Okay, so the amount of loops gets bigger and bigger. So what I assume that happens is that this keeps building and then it drops down because one bit is somewhere flipped. Still going up, still going up, still going up. Do they keep going up? Ah, this is the running total. Let me do a local. Let's see, local high, do that as well. Local low. Okay. Let's go back and see if we can spot something from the first 100. I don't think so. So we have 9 and 33, 29 and 84. Is that true? I don't think so. So this still keeps adding. Did I do something wrong? Ah, I need to reset them. So we do local low is local high is 0 like this. Okay, let's run this again. Bum, 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 bum. 933. Oh wait, I need to reset them inside here. My bad. Well, it's not true because it keeps adding there. Okay, my bad. Okay, let me go. Let's see. But it just doesn't feel like there are this many here. These are not 71 lines, right? Versus, well, it might be, versus 40, okay. 933, then 2051, then 933. Okay, so it keeps growing on the second one. So does it default back to 933 every time? Okay. 2051, 933, 170. 2051. Okay, so there is some sort of pattern. Okay, let me see. If I just take this one out, let's not write out this one, and just look at the counts. And now I can just also take away this one actually. So it's 933, then 2051, and you see the 2051 repeat a few times as well. So they have 2962, and then you have this one increase. And then you have the same 933, 2051. And then you have this one, does this repeat as well? 2962, okay. Then 45 high, and then this one repeats. Is it an ever increasing pattern? That's interesting, because you can see this one, then this one, then this one, and this one, then it repeats these two, and it goes back, and then this one becomes bigger. But then it repeats this one as well. And then this 37, I think it will repeat here. You see? And then it will go to this state. So the bigger one would be 45 and 75. And I assume we will see a 45, 75 here. So, okay. So this pattern grows. And it will keep doing the previous steps there. So that is interesting to me. So the big one here will be the 62, and we should see this one, the 62 value, repeat down here somewhere before we run out. 45, this has the 37 and the 29. 20. So here's the 45 again. So the next one that will be bigger is the 53. Okay, so this one is a shift. Okay. It's interesting. Is there a way for me? Let me think. So what I could do is have like an emit state. So we can do a dictionary string comma bool emit state is modules dot select just to dictionary actually, not to dictionary key, and this is incorrect for the start, right? So I can do emit state pulse dot from is pulse dot value, right? This one will set me the state for each one of those. So what I could do here is console right line, and I can do a string dot join, and this one will be emit state dot select x dot value 1 0, right? Boom. So this will be a binary representation of what every one of those things emits to others. Dun, 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 dun. Is this long enough? The amount of pulses doesn't matter. Let's see. If I now also make a dictionary of string, comma, and this will be int first, int count. No, let's just make this a hash set int scene is new. So let's make this a key. We do string key equals this. Right line key. And let's do if not scene try get value key comma out var previous is new, like this, and then we do scene.add scene.add key comma previous, and here we can do previous.add I. Now we can do this scene times before at this. So this one will be previous.count. This will be string.join, just comma separated previous, like this. And let's do this for 1000. This will probably go a bit nuts, but This makes sense because every state is unique. And there's no repeats. So in the first 1,000, every state we see is unique. It makes sense. So what I probably would have to do is diff between those. Okay, so that's not it. Let's take away this one. Let's also not even do this part. console.writeline key. Let's see if there's a pattern to be spot here. So this one flips, these two flip. I should probably still have the low and high here. So just that I can see the pattern that I saw previously. So we do the key, local low, local high, low, come on, local high. So what I should probably do is also sort these by type. Let's do that. Emit state. Let's do that order by. Just sort them by that, so that at least the types are grouped together. Then by x of key is fine. So if I do this now, there are 2 bits changed here. And then there are 3 here. Okay. It's funny to see this. It's still not enough to work out a pattern from this, but I think there should be a way to detect some sort of pattern, because we can see the stable. Or like at least in low high counts, you can see it every time falling back and then expanding into another thing that makes it go bigger, and then falling back and then repeating the previous cycle. And so I think there's something to that. I just don't have the knowledge right now to do this. So I think I will end it here, because I still need to have breakfast actually. And there's a bunch of stuff that I have to do for the family this afternoon. So I will end it here and see maybe if I can revisit it tonight. Because this isn't the path that is getting me to the solution. What I should have probably have done is to take this input and try to reverse it. And then from there see, but there's still, I think like the state that you have to run is so big. That I probably think that you can't brute force this. Well, maybe you can, but I'm not going to let the brute force run. because what I think that you need to do is work backwards with this one, but even then it's the same amount of steps that you have to run, so that doesn't give you the answer. There needs to be a way to predict, like as you do an iteration and a cycle, it will flip one bit. So that's why I think you really need to work out what the machine does to certain states. So I should probably have like a nice visualizer that lets you see the type of registers that we have and how they change based on the loops that we do. And based off of that, I think you might be able to extrapolate how it will move further. So once you can work out what it takes to change one thing, you'll be able to figure out how many times you need to do that. So it's probably tracking those cycles and patterns, and yeah, I just don't have the time or even the brain power right now to do that. So we'll end it here and revisit that later. So I want to thank everybody for watching, and I hope to see you again tomorrow or maybe tonight.